Good morning, class, and welcome to our last week of new material here at Math 104 Trigonometry for the spring of 2020. So today we're going to talk about section 10.3, polar coordinates. And we're going to go the first two objectives here from page 778 to 791, with our first objective being plotting polar coordinates. So what we have here is a new type of coordinate system. So before we had the rectangular coordinate system where I have an XY horizontal and vertical axis and then subdivided by horizontal and vertical grid lines with the coordinates being X and Y at any particular point. Now we're going to have polar coordinates where our axis we have a horizontal and vertical line axis, but we have concentric circles, and our coordinates are going to be r and theta. So let's look a little bit more in depth at the parts for our polar coordinate system. So here I have a general rough polar coordinate system drawn up here again, and I have a point on it, but notice that I got my horizontal and vertical bars or axes on the coordinate system. Different parts. The pole is the origin. So that's our old origin point in the XY coordinate system. Now it's the same point in the polar coordinate system. The polar axis is the positive x-axis. So here is the polar axis right here, the positive x-axis. And then around the pole I have concentric circles at different unit values. So 1, 2, 3, and 4 here. Notice they can be positive and negative values though on the horizontal and vertical axes. So here I got positive 1 through 4, positive 1 through 4, negative 1 through negative 4, and negative 1 through negative 4. My coordinates on my r theta is the coordinates, where theta is the angle right here. I should have drawn it in there. Let me do that. So there's theta right there. That's that angle. And it goes out to a point on the concentric circles. So here's the point 3 at pi over 4. So my r is measured axially from the pole, out from the pole. It can be positive in this direction, or negative down in this direction or this direction. Theta can also be positive or negative. Theta is measured counterclockwise from the polar axis. So it goes counterclockwise over here. So here I have a theta of pi over 4, which is 45 degrees. So here in our polar coordinate system, our theta is measured in radians. So theta is measured in radians. I should have put that up there. And it can be also negative clockwise from the polar axis. So here we should have radians. Okay, and there I have a point plotted at the value 3 on the r, and then, so this is r out this way, there we go, and at pi over 4. So you can see where that would be. So let's look more closely at plotting points in the polar coordinate system. Okay, so let's take a look at example 1. We're going to plot the points in our coordinate system. We're going to plot this particular point, 3 pi over 2. And so notice how we write it just as we wrote an ordered pair in an XY coordinate system. So r is first, theta is second. So r theta in the same manner in parentheses. So here I have my polar coordinate system over here with my polar axis, positive this direction, negative this direction, and my concentric circles for 1, 2, 3, and 4. So I go out from the pole, out 3 units in pi over 2. So notice remember my theta is measured counterclockwise from the polar axis. So this is 0, pi over 2, or 90 degrees, pi, or 180 degrees, 3 pi over 2, 270 degrees, and back to 2 pi. So normally we measure it counterclockwise from the coordinate system. So here it's measured out counterclockwise up to pi over 2, and then I can write the coordinates on there, 3 pi over 2, in the same manner that we would write coordinates, an ordered pair in an xy coordinate system, only now there are theta. Let's look at another example. Okay, this is try it 2, right under plot example 1. Try it 1, excuse me, right under example 1. So we're going to plot 2 pi over 3. Okay, well, pi over 3, 60 degrees. So at 2, so it's going to be on the concentric circle 2. So I got 2 units at an angle here, theta of pi over 3. And I put my dot, and there's my point at 2 pi over 3. Let's look at some that might have a negative with them. So let's look at example 2 here, where we're going to plot negative 2 pi over 6. So here I go out in the negative 2 direction, this way, from the pole, but pi over 6. So pi over 6 is a reference angle from the horizontal axis. So then I go down pi over 6, or 30 degrees, and I can put my point at negative 2 right there. Okay? Let's look at one more example here of plotting. So the final points I'm going to plot here is try it 2, where I'm going to plot 2 points. The first one is 3 and negative pi over 6, and the second one is 2 and 9 pi over 4. So let's take a look at the first one there, 3 and negative pi over 6. So it's a negative angle, so that means I go clockwise from the polar axis. So here I've gone out to a point 3 on the concentric circles, and I go down a theta of negative pi over 6, or 30 degrees in the clockwise direction. I put my point, and there is 3 negative pi over 6, and I can label it. My second one here is B, where I'm going to plot 2 and 9 pi over 4. Okay, so 9 pi over 4 is greater than 2 pi. Remember, 8 pi over 4 would be 2 pi. So 9 pi over 4 goes counterclockwise, one complete revolution, and comes back, crosses the polar axis, and goes up to 45 degrees, or pi over 4. So that would be 9 pi over 4. So remember, here's 1 pi over 4, 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, which would be 2 pi, and then 9 pi over 4. So actually make one complete revolution and come back to pi over 4 in the plus coordinate quadrant number 1. So our quadrants are labeled the same way, 1, 2, 3, and 4. So it'd be up in quadrant number 1. So for objective 2 now, we're going to look at converting polar to rectangular coordinate systems. So we want to be able to convert between the two systems. And here's where our trigonometry comes into play. So here I have a rectangular coordinate system overlaid on top of a polar coordinate system. So the polar coordinate system is in blue, the rectangular coordinate system is in black. So here I have the x-axis, y-axis, which is for the polar coordinate system, 0 and 2 pi, pi over 2, pi would be over here, and 3 pi over 2 would be down here. Inside and I can see I got concentric circles at 1, 2, and 3, and I have the rectangular coordinate system overlaid on top of that. So in the rectangular coordinate system, well, in both coordinate systems, I draw a general right triangle. So here's a general right triangle here, drawn at angle theta out to r, and on the opposite side I have the y measure, and on the adjacent side I have the x measure. Okay, so I can look at theta and take the sine and cosine of theta. So if I take the cosine of theta, that's adjacent over hypotenuse, which would be the x measure over r, x over r. And then sine theta, opposite over hypotenuse, would be the y measure over r. So sine theta equals y over r. If I solve both of those respectively for x and y, I get these two relationships. X is equal to r cosine theta, and y is equal to r sine theta. And those are laid out in the box over on page 790. So let's look at these in some examples. So this is example 3. And we want to convert the point in polar coordinates 3 pi over 2. So right over here I have the polar coordinate system and the rectangular coordinate system laid out side by side. And they do that in the book also. So here at 3 pi over 2, I have a point there. So x is going to be r cosine theta, or 3 times cosine pi over 2, which is 3 times 0, or x equals 0. Y is equal to r sine theta, or 3 times sine pi over 2. 3 times 1 is 3. So my xy coordinates then are the point 0, 3, which I have right over here, 0, 3. So you can see it's in the same relative position in both coordinate systems. Let's look at another example. My next example is going to be example 4, where we're going to convert the point -2, 0. So -2 is the radial, the r factor, and 0 degrees, which means it's right on the horizontal axis. So x is equal to r cosine theta, or -2 times cosine of 0. So x is equal to -2 times 1, or -2. Y is equal to r sine theta, or -2 times sine of 0. Y is equal to -2 times 0 is equal to 0. So my xy coordinate then is -2, 0. So here I have both points plotted in. A -2, 0 in the polar coordinate system, and -2, 0 in the rectangular coordinate system. And you can see they're in the same relative position. Okay, which is something to consider, same relative position. Let's look at one more example here. So for our final example of this conversion, we're going to go back to example 2, where we had the point -2 and then pi over 6. So we saw this where it was right here, -2. So I go out -2 units in the radial direction, and at pi over 6, which would be the reference angle from the x-axis, or the horizontal axis, I should say, of 30 degrees. So let's convert that. And see, I plotted it right there, -2 and pi over 6. So x is equal to r cosine theta, or r cosine pi over 6. So x is equal to -2 times 0.866. So in the book, the answer will be in a radian, square root of 3 over 2. But I put the decimals in there so I can get an x value that I can plot. So that's -2 times 0.866, which is -1.7. Y is equal to r sine theta, or -2 times sine pi over 6. And if you want to review your unit circle values, look at page 615, which has all the unit circle values on them in a big circle. So y is equal to -2 times the sine of pi over 6, which is 1/2, or -1. So then my xy coordinates are -1.7 for x and -1 for y. -1, -1.7. So here I have it plotted in the rectangular coordinate system over here, -1.7 and -1. And you can see that pretty much lines up with the same relative position in the polar coordinate system of -2 and pi over 6. So that's all I have for part 1 of this week's lesson. Part 2 will finish up the section and maybe get started in the next section. But this is all the new stuff we'll have for the course, what we have this week. I will also point out that the final will be next week. Remember that Monday is a holiday. That's Memorial Day, so on Monday that's a holiday, and then next week will be the final. I'll be giving out the final on Wednesday to return on Friday. So it'll be the same relative size as the other tests, and I'll tell you more next time of the sections but it'll basically covers the whole course. So it's comprehensive, so it covers everything that we have covered in the course. Again, we'll also have I'm planning on having a Zoom session on Friday. So we did have a couple of people show up for the Zoom Zoom session this last week, so I hope some more people will show up this week for questions, especially on this polar coordinate system. I know that can be confusing, but at any time, if you have any questions, you can always email me for any questions, and I'll be happy to answer them, get back to you, answer them, and get back to you. But so until I see you or talk to you again, stay safe, stay healthy, and we'll talk to you again soon.